Hi, I'm Jack McDonald, the current president of the Amateur Astronomy Club. Here, we present a closer look at the Veranda Telescopes. Currently, there are 6 telescopes on the 5th floor veranda of the COAS. They are used for the Intro to Astronomy lab courses. Dr. Stephen Gillum is in charge of all telescopes on the 5th floor.
I'm Dr. Steve Gillum. I do 2 things here. One part of my job is to maintain and develop the telescope systems, including the 1 meter telescope and the telescopes out on the veranda. The other part of my job is teaching the astronomy labs. We provide possibly a first experience of astronomy, of and telescopic operations. We offer a range of experiences, astronomical experiences ranging from CCD astronomy, CCD imaging and calibration and analysis of data, all the way through to spectroscopy at the end of the semester. So here's one of the cameras, one of the CCD detectors that we use. You can see in the front here, I think, the shiny unit. That's actually the chip that is sensitive to light. It's much like the chip in your phone camera, a charge-coupled device whose main job is to take particles of light and convert them into electrons, which are stored and then read out and made up into a picture.
Students with an astronomy major or minor have the opportunity to take this class. It runs for 3 hours on weeknights. The first couple weeks of the class are centered on learning how a telescope works and what the CCD does.
This is a camera. It's a CCD camera consisting of a lens, the objective lens, the big lens at the front of the telescope tube, and our camera, the most important piece of which is the CCD chip here, which is light sensitive. So light comes in through our lens from a distant object, a star, a galaxy, the moon even, and is focused by this lens. An image of the star is formed in the form of electrons, actually. Those are then amplified and converted into a numeric value, which is sent to a computer.
As with any data taken from any telescope, the data eventually needs to be calibrated. This process is also taught during this lab.
So now we're outside actually looking at what was diagrammed earlier. This is what's commonly referred to as the telescope tube. Here's the CCD detector with that all-important light-sensitive chip in it. And in between the detector and the lens, we've inserted a wheel unit that actually has 5 different filters in it. This is the mount. It does more than just hold this, it actually drives the scope around precisely. Here are the counterweights. These weights balance everything above the fulcrum here. Of course, this is pointed at the North Celestial Pole, which is over there. And the whole thing sits on this rigid pier so that it's high enough up above that we don't end up sort of below our own horizon here.
Dr. Gillum works diligently to prepare laboratory activities for the students night in and night out. He employs teaching assistants to help instruct this highly technical lab. One such TA is no other than Joey Hamill.
Hi again, I'm Joey. I took 318 2 years ago now, and I was also got to be a TA for the lab, which means that in addition to being a student myself and using star analyzers, using the CCDs, I also got to teach this lab a little bit, which was a very nice experience. It's very rewarding to get to teach the students in up-and-coming labs. And some of my favorite experiences with these, we use the star analyzer, this little star analyzer here, and we took spectra of different stars of all 7 spectral types. And my partner and I got a very nice picture of the Rosette Nebula, which includes about 30 minutes of exposure in H-alpha filters. These telescopes are powerful enough that you can take different images of stars, including variables, and analyze them in the same way that we do with the 1 meter, and build up light curves. And these telescopes have a little bit of a wider field of view, and so we can analyze bigger clusters, a bigger field, and use AstroImage-J and other analysis software just the same as we do with the 1 meter.
These laboratories offer the perfect introduction to scientific observational astronomy for the beginner as well as the experienced amateur astronomer.